And then this area have been around maybe 15 to 20 years. Maybe it might be 5 more years for each, but yeah. Yeah, and the next page is a lot of text, but this is my own kind of summary or kind of impression about this visual analytics. So as a kind of a third new area in this visualization, there is something called visual analytics that we focus on. And so visual analytics is mainly related to InfoViz rather than SciViz. So we still handle some abstract data, but it tries to overcome the following limitation that this InfoViz has. So the drawback of this InfoViz is that this InfoViz is focusing on the given data as it is. So we do not try to process or transform our data. Okay, so we just try to visualize our given data in its original form as much as possible. Okay. So one example of this InfoViz technique is this word cloud. Okay, word cloud. So probably you guys have seen these types of text visualization, right? So this is just one representative topic in the InfoViz. So in that case, the input is, it can be just raw text, but we can simply count or compute the number of occurrences of each word, right? And then, these are really simple measure, and then they can be treated as just our original data. And then how can we effectively visualize those number of occurrences of each word visually? Okay, in that case, we can simply encode the number of occurrences as the font size, but at the same time, how we can visualize these or layout or place each of these words in a really packed form, right? So that is like the one that I was talking about, like this kind of visualizing the data as it is as effectively as possible. Okay, so we can just list those keywords as just in a horizontal line with a different font encodings, but it will take a lot of size in our screen space, and then we might have to scroll a lot horizontally, for example, if we do not pack them really nicely, right? So how we can effectively visualize in really limited spaces while we can understand them really intuitively and quickly. So that is one representative topic in the InfoViz. Okay. So InfoViz can sometimes involve really algorithmic and mathematically heavy aspects. So how can we compute the algorithm? How can we develop the algorithm to really pack all these words vertically, sometimes and horizontally, in this nice layout? So that is not trivial to develop. I mean, in terms of it's an algorithm. So they also they sometimes InfoViz folks sometimes work on these algorithmic aspects a lot as well. Okay, so that was an InfoViz, but the as the big data era is coming, where we have so many data items and so many features, and they sometimes stream in a streamed format, and also with the loss of noise. So we have to filter out a lot of parts in our data, and then transform these data so that the transformed data can reveal some interesting aspects. So that kind of aspect is emphasized in the visual analytics. So in the visual analytics pipeline, rather than just visualizing the data as it is, they go through some data processing module or data mining or machine learning algorithms before we visualize these data. Okay, So we actually visualize those transformed data instead of these original data. Okay. So that's a typical pipeline done in this visual analytics techniques. Okay. Okay, so that is about this part. And then what kind of a processing of our data or analysis techniques that transform this raw data or original data into some processed format of the data? I mean, the selection of the particular algorithm is really dependent on our task. So depending on this task, we can use a different algorithms. So it's naturally really task oriented, as I mentioned before. So if we want to analyze some clusters and their outliers with respect to these major clusters, and then we can perform some clustering and outlier detection algorithms here. And also we may want to analyze some misclassified data in typical supervised setting, and then we set up some supervised setting algorithms, and also we extract out or we obtain some data items that are misclassified, and then those data are selectively visualized with the reason for why they were classified, for example. Okay? So those kind of reasons for why they are misclassified, and the selected data or subset of those data that were misclassified, all those data processing is done here. Okay. And then it's not just visualized, it's not the end. As I mentioned, we interact with these visualization and also sometimes the raw data and sometimes these algorithm modules as well. Okay. So this is overall kind of big picture in this visual analytics. Okay, and then here are some quotes that highlights the needs for the visualization or visual analytics. So the main idea of visual analytics is to try to leverage the advantages of both computers and humans. And so Albert Einstein said computers are incredibly fast, accurate, and but stupid. But human beings are incredibly slow and inaccurate, but quite brilliant. So when combining the advantages of both, the results can be really powerful beyond our imagination. Okay. So yeah, this kind of quote is highlighting already the needs for the visual analytics. And then here are some research areas in the visual analytics. So if you are having some issues related to those, and then you might want to check some literature in this visual analytics domain. So as I mentioned, in this pipeline, it's already when plug this part in with machine learning modules, then we can really support this visual analytic process where humans are analyzing the data visually, but with the help of this machine learning algorithms. It could be classification, regression, and clustering, and so on. Okay, so in this case, still the task is from our end. So we have our original task, which might not fit, which might not be fitted to a particular machine learning algorithms. So our task is kind of quite complicated, which is not easily formulated as a particular machine learning algorithms. And then we may be able to use this machine learning, which does a particular job. Then we can use that. Yeah. 네. 네.
그거를 줄이던가 해서 없애던가 줄이던가 해서 3D로 옮겨갔다가 그 비주얼을 보고 다시 그 해석을 해서 다시 그 어떤 방식으로 해야 그게 수학적으로 뭐랄까 이게 가능한지.
Okay, so the question is about the limitation of visualization done in a 2 or 3D space, right? So in order to visualize some data, that have to be visualized in a 2D or 3D because we can only see those three-dimensional space, up to three-dimensional space. But typically the data that we deal with is really high-dimensional and the number of data are so many. So somehow we have to reduce the dimensionality of our data, or if the number of data are so large, and then even if we visualize the entire data all at once in our screen space, we cannot observe all these, for example, millions of data and their characteristics represented visually, right? So we cannot observe all these information when the visualized information is too large. Okay, so so that's the basic limitation and main limitation, and many people have the same kind of questions when when exposed to this visualization. But the answer is, I mean, we have to take that. I mean, so there is the only way, I think, and so we have to find some best, I mean, the optimal or the suitable way to map the high dimensional data into two-dimensional or three-dimensional space, and then also another suitable method that maps the 2D data to the high dimensional space. But that one, so in that kind of task, fundamentally there is no single best and perfect answer. So it can never be perfect. But we do have, or we are equipped with some interactions, right? So we can try out different types of dimension reductions so that we can see different aspects of our data. So in that case, even though one particular 2D visualization result may have some distortions, that can be compensated by some other visualizations computed by other methods. And then also those kind of so in terms of reducing the number of dimensions, we can try out different parameters and different methods, but also we can also do some because of these significant distortions done in this visualization. But we don't have any other alternatives, right? So even though the visualization is not perfect, sometimes I often find the cases where some important or really major characteristics are emerging in some visualizations, although that visualization involves a lot of distortions. Okay. So personally, I think this visualization will definitely help you deeply understand what's going on within your model, especially when your model is really working in a complicated manner, and also based on a certain such kind of understanding, we will have a clue, or we will now have like an idea about how we can improve or how we troubleshoot or debug our models as well. Then Okay, and then yeah, so sometimes our task is much more complicated than just a simply formulated machine learning test. So that's when visualization can help. But also the other task can be also the other direction is also possible. So we want to still focus on solving some machine learning tasks. I mean easily formulated machine learning tasks, but we want to improve the performance of the machine learning tasks through the interactive visualization. Okay, so for example, we identify some misclassified data or some problematic dimensions through this visualization, and then we can remove them, or we can just use them more often to make our model better on these difficult or misclassified data items. So that's one kind of an interactive way of this improving the machine learning methods. Okay, then the other area is this large scale visual analytics. And yeah, simply when you have like millions of data, yeah, you might be surprised that there are not many available softwares that can visualize like millions of the data. Okay, so if the data items are maybe several hundreds or thousands, and then you may have really many different options to visualize them. But if it's more than like 10,000s or 100,000s, and then yeah, many of these existing visualization systems and tools cannot accommodate such kind of a large amount of the data. So yeah, it's a pity that the visualization cannot handle those large scale data, but still it's quite actively studied or researched. And so yeah, so this is another area, and then the other one is collaborative visual analytics. So like so you are working in a team, and then each team member will do some job in the one single analysis tasks, and then we want to share our analysis result through these visualizations so that they can also do some interactions on the results that we created. And then in that case, we want to share and then also collaborate in real time with the others through this visual analytics. So that's another area. And then there are so many different applications. Yeah. And then yeah, in the latter part of the class, yeah, we may probably see yeah, some numbers of the application-driven visual analytics system papers. Okay, then let's see. So it's okay, it's 4:45. So yeah, let's take a break briefly, maybe 5 to 10 minutes, and then yeah, continue after that. Okay. 네.
아
블록
맞다.
같은 거 되나요?
아, 네, 돼요. 네,
블랙보드.
네, 돼요.
아, 지금 아주 험불하게 이런 식으로 막 플라팅을 해주고 있어요.
아.
프레임마다 어떤 음소로 가장 높은 프로버빌리티를 예측하는지 이런 걸 좀 더
간지나게.
유의미하게
그렇죠.
네,
네, 영어로는 팬시하게 그죠?
네,
팬시하게.
세계 모든 사람들이 그런 걸 좋아하니까 이게
네.
각자 다 언어들로 있죠. 네. 네, 그래서 이제 네, 뭔가
영상을 바로 인풋하면은 이런 아웃풋을 그려주는 그런 거 만들면
네,
가장 좋을 것 같아요.
네, 좋을 것 같아요. 그 아마 그런 것들은 그 저기 좀 앱스트랙트한 어떤 조금 약간 좀 뭐라 해야 될까? 네, 말 그대로 그런 조금 뭐 이렇게 난트리비얼한 프로세싱을 통해서 이제 이루어진 비주얼라이제이션은 아닐 수 있고, 그죠? 그러니까 지금 현재까지는 그거는
네네네.
그냥 베이직하게 이제 한
네,
거잖아요.
완전.
근데 뭐 그런 것들을 뭐
안 베이직하게 하고 싶어.
완전 그냥 숫자 세서 한 거예요. 그래서
네. 그래서 걔네들을 일단 내가 아는 한에서는 그런 디멘전 리덕션을 써봤고요. 그
네.
시간대별로의 그 피처 벡터를 저기 인풋으로 삼아서
예,
걔네들을 2D로 보여주고
네.
그 걔네들의 어떤 그 2D 맵상에서 이렇게 트레젝토리를 좀 이어서 그러니까 뭐 0.1초 단위, 100ms 단위로 뭔가를 뽑았다라고 하면 그때마다의 피처 벡터 우리가 뽑아낼 수 있잖아요. 그 피처 벡터를 쫙 비주얼라이즈를 하고요. 걔네들에 대한 뭔가 작년에 이제 했던 그 MDS나 아니면 뭐 그 TSN이나 뭐 이런 거를 해갖고 비주얼라이즈를 하면은
음성 쪽에 그걸 적용한 거 보시면 거죠.
그 시퀀셜 혹은 템포럴 데이터를 직접적으로 써갖고 뭔가 비주얼라이즈 한 거는 못 봤어요.
HMM 같은 거 안 가고 그냥
네.
피처 벡터 자체에서 어떤
네.
DNN을 직접 간다던가 그런 식으로 해서 한 거는
네.
저희는 해본 적이 없어서
아, 그러니까 그게 어떤 모델 잠깐만요. 인터넷이 너무 느려갖고 이런 것도 나오려나?
음성인식 거쳐서 나온 결과를 지금 플러팅하고 있는 거잖아요.
네.
인풋 MFCC 피처 벡터를
30 by 30 adjacent matrix, right? Let's see. Okay, just to simplify the scenario, suppose we have 4 people, and then those two and those two. These are connected. For example, they have a friendship relationships, or in these kind of classroom settings, they are taking the same class. Okay, and then these edges are encoding such kind of information. Okay, taking the same class, and then we can construct this kind of adjacency graph. So it's corresponding to 1, 2, 3, 4 person. Then all of them are 0 except for those edges. So here we can have 1 as an indicator of having edges, right? And 1, 3 and 1, 4, and then also is undirected one. And then did I miss something? 3 and 4, right? 3 and 4, right? So this is our adjacency graph. Okay, and then we can just serialize these graph or adjacency graph or matrix into one vector. So let's see. So this vector is concatenated into this, and this, into this, and so on. So that way, we can form one particular feature vector describing one particular time point. So at 5:05 p.m. on Monday, we have all edges between us, ourselves, right? But we go back to the office or go to different classrooms, and then we will form another adjacency matrix at that time point, right? And then we can think about this kind of feature vectors formed by this at each time point. And then we can just reduce or project or embed them into 2D space, so that if they have an edges, and then they should be located closely. Okay, so that is the main idea in this graph embedding. And then yeah, these are the embedding result of such kind of graphs. And then these edges are showing the adjacent time points. So this one was 505, and then this one was 605 and 705, and so on. So we can form this kind of trajectories of these feature vectors. I mean, dynamically evolving feature vectors over time, right? And then if we see a particular pattern, so every Monday you guys will have the exact same class, right? And so each hour, I mean this feature vector and their transitions over hours within, for example, Monday, will virtually have the same patterns. It may be a little bit different because some students might miss some classes on a particular day, right? And so it might be different, but if they are largely having the same pattern. Okay. Okay, and so back to these slides. Yeah, so in general, as Einstein said, yeah, it would be great if we can combine those computational aspects. I mean, what computers are good at and also what humans are good at, right? If we combine both, then it would be great. But there are some inherent or fundamental limitations from my perspective. So yeah, it's the same as what I mentioned in the previously. So these are machine learning. Will take an input as some data, and then give some output as numbers. But when we consume or when we utilize as a human or as a data analyst to analyze these numbers, they will be just we will just look at these numbers, but they can be visualized as a simple form of bar graph or line graph and so on in our screen space, and then we can have some interpretation and some understanding or capture some patterns from these visualizations, and then do some interaction with these these data and machine learning models and so on. But yeah, most of these machine learning methods are only caring up to this point. So they do not care about how these outputs that they generated from a human's perspective, and what are really the humans' end tasks or the task goals. So yeah, so these are machine learning methods is just do the job that they are asked to, but they do not care about what humans are interested in sometimes. And so there is a kind of gaps between gaps in here. So I think this machine learning methods should be more interpretable, user interactive, and real-time responsive. So yeah, from purely this machine learning aspects, these machine learning methods should be improved, or there's a lot of room to improve these machine learning methods so that the result of them, their results can be more interpretable and user interactive, and real-time responsive as well. Okay. Yeah. So yeah, there are many examples of visual analytics. So in this case, I showed this example too many times, so I'll just skip this. But in this case, there is a method called the topic modeling, and in this research, we try to make this topic modeling process more interactive. So the topic modeling should take additional input of user feedback. Okay, but most of the machine learning methods doesn't have a capability of taking the user inputs. Okay, so okay, and then let's see. Yeah, since it is a cool looking video, let me just show the demo video of this work. So this is a vision analysis system that visualizes high volume text streams. Streaming, it tries to visualize the streaming data. And then it's like using this river metaphor. So a particular topic from some text data is represented as one kind of a stream with a particular length, particular width. So if the width of the river is large, and then it means at that particular time point, which is on September 9th, I mean the topic about these keywords have a large portion. Okay, and so we can show these topic evolutions over time using this streaming graph. Okay, and then it shows. So this is a current time point. And then the data items that we collected just now will have more importance, right? And so instead of just aggregating them into a particular river, we individually visualize each of the documents as a single dot. Okay, and then over time they are merged into a particular river according to their relevant topics. Okay, then we can see in real time what individual documents are about in terms of their topics at a particular time points. Yeah, in this manner. Okay, and then they also used this interesting visualization of diverging rivers, so that splitting topics over time. So if one topic diverged into a multiple different subtopics, and then they also visualize them into this splitting kind of river streams. Okay. So at this point, it was separated into multiple subtopics, and then they sometimes are merged together and then crosses over and so on. Yep. Then also geospatial temporal data and their visualization is really important topic. So if we look at something like a Google Maps, and then if that Google Map is giving some useful information for our own tasks, and then it will be really useful. So if we want to detect some infectious disease, okay, and then we want to be able to detect it as soon as possible, and also we want to spot where is the origin, right? And in that case, we can have some kind of map-based interface, and then overlay some useful information that we extracted out of these, for example, raw tweet data or any kind of interesting data, right, that we can utilize, and then we extract out those useful information for our own task of detecting these kind of disease. And then these information can be visualized on top of this map type of view. And although this is not clear, but it's actually showing some map, and then it is showing, I believe, some movements of people between the cities, right? So usually the people from this region is moving to these regions and so on. And then if we click some other regions, and then it will show different patterns, and then it has some other views so that we can kind of analyze the different aspects of the data in different views. So yeah, so this is another example of visual analytics system driven by a particular real-world task. This is another view, another example, and this is about the network data visualization. And yeah, this is another best paper or second best paper written by this guy. Okay, so this guy received the best paper or second best paper back to back in 2 years. Yeah, and he's really very good at developing all these systems, and he's carrying all these nice little widgets and nice and fancy interfaces and nice colors and things like that. But it's not web-based, although yeah, the web-based is a current trend. It's implemented in C# or yeah, Visual Studio. Yeah. Yeah, so even though this part is shown as a map, but it's just one example of using the coordinates of the data point when using this geo coordinates. Okay, the latitude and longitude, we will use them as a coordinate of each point, and then we will show their edge or adjacency relationships using these edges. Okay, so that way this visualization is created, and also this is a kind of abstract version of that one. It's like, so we specify some interesting regions, okay, for those 4 corners. Okay? So suppose we are interested in all these 4 extreme corners, and then want to focus on their interactions at this group level. And then each of these rectangles are corresponding to those 4 rectangles, and then their edge relationships are aggregated using these. Okay, so also these kind of self edges are also shown. Okay, so I don't know, it could be maybe some friendship relationships, or maybe some phone call data, and then their each person's addresses. Okay, and then we can see that within New York, people are calling each other a lot, yeah, compared to Washington. But California doesn't call each other. I don't know why, but yeah, things like that. Yeah, and also more recently, this kind of 2D map-based visualization, 2D embedding-based visualization have been also adopted in TensorFlow visualization modules. So TensorFlow, which is a popular deep learning library, has a kind of visual analytic tool called TensorBoard. Okay, I view that as one nice visual analytics, although that doesn't have like a fancy visualization components, but it shows real-time statistics. I mean, in real time during the training process, so that you can better understand what's going on during the time-consuming training processes. And then also, it just uses a basic statistical graphs like a bar graph and the line graphs and so on. But it's quite effective. Yeah, so yeah, some of my students here said that it was quite helpful in debugging and troubleshooting the problems in the particular models that they use. Okay, and then recently they added this 2D embedding visualization techniques. Oops. Yeah, this is a real website, but I want to just show you some. Yeah, especially they used this 3D. So yeah, because we can see up to 3-dimensional data So why not using just the 3D all the time? So based on that kind of motivation, they adopted this 3D visualization instead of just 2D. But it's really debatable whether 3D is always good or more advantageous than this 2D visualization. Because 3D visualization is also having its own problems, which we will see later in the class. But yeah, anyways, in this manner, they allowed users to explore the representation at a particular layer, including hidden layer and also the input layer as well. Yeah. So personally, yeah, I'm together with some other student of mine. Yeah, I'm working on this system and then try to accelerate the algorithm used in this embedding projector, and also provide some interesting capabilities in this on top of this embedding projector. Yeah, and see. Yeah, so if you are more interested, and then these are the pointer that you can start to look at. So these IEEE visualization is the top tier conference. Okay, and then this one is actually composed of the 3 conferences that I mentioned, including this SciViz and InfoViz, and then Visual Analytics, and specifically the name is Visual Analytics Science and Technology. Yeah, and then the second tier or 1.5 tier conference is called this Euroviz. And then this Pacific Viz is a regional Asia Pacific conferences. And for your information, this conference will be held in 2 months in Seoul National University in Korea. So if you're interested, yeah, you can check out the website. Yep, and then, yeah, although I just briefly mentioned, but I try to publish those visual analytics oriented research also in these machine learning and also data mining venues. So the main trick is that we can actually improve the machine learning methods so that they can incorporate the user interactions. And then the method will be like a new method, right? So such kind of a method that have an interactive capabilities. I mean, that will, yeah, that kind of work can also be accepted in purely machine learning and data mining venues. Yeah, and sometimes you can, yeah, it's really a niche market where not many people tried, not many people explored this kind of areas. Yeah, so any questions so far? Yeah, I'm debating whether to continue to lecture 2 or not. Okay, then yeah, let's just finish the lecture today, and then continue next week. Okay, that's it, and thank you very much.